The RISKSUR project was a project carried out between 2012 and 2015 and funded by the 7th Framework Programme of the European Union. The project aimed to provide those designing animal surveillance in Europe with science-based frameworks to guide them through the systematic process of surveillance design and evaluation. This video will focus specifically on the surveillance design framework. For an overview of the other tools available and how they integrate, you should refer to the RISKSUR website, in particularly the training and webinars available in the tab Results, or to the website of the Santero project, which has continued the achievements of the RISKSUR project. Or refer to the Surveillance Design Framework Wiki, which will be covered later in this video. The Surveillance Design Framework is a guided tour of the process of designing surveillance. It does not take decisions for the users and does not assess quality. It's also not meant to teach users about surveillance. Rather, it supports competent and technical level users who are already experienced designing, implementing, or evaluating surveillance strategies for infectious livestock diseases within the European Union. Likely, this will be not an individual, but a team. Informed by extensive literature reviews and several rounds of expert opinion, a surveillance system has been defined in the framework based on 5 characteristics: objective, hazard, geographical coverage, target population, and risk characteristics. A surveillance system would be, for instance, the system against blue tongue in Germany with the objective of disease freedom documentation. A system is then composed of several components, which are the different activities carried out to achieve the objective. Each of those components needs to be designed in a number of different dimensions. In the surveillance design framework, this has been structured through a set of steps. First, at the system level, defining the 5 characteristics listed. Then, helping the user define all the surveillance components existing or that need to be implemented. And finally, iterating through steps 3 to 14 for each specific component in order to design them. The goal of the surveillance design framework was to gather all the information that a user needs in order to go through these steps, list all the things they need to think about, decisions they need to make, information they need in order to make those decisions, and then structure them through organized steps. This has been done through a web tool supported by the contents of a wiki. In order to understand how those two parts work side by side, we need to take a look at them. The applied tool is available at this address. You can pause the video to copy the address or click on the link provided in the information of this video. Anyone can register for an account in the web tool. In this web tool, you'll find both the surveillance design framework and the complementary tool, the evaluation tool. You can find information about the evaluation tool in the resources I've listed earlier in this video. Following the structure I have shown in these slides, the surveillance design framework starts with defining a surveillance system. When you try to create a new surveillance system, you're guided through defining the set of characteristics I have listed before. You just have to answer the questions and click Next. You can see all the existing surveillance systems that you have created and are therefore private to your user login. But we have also created and saved some case studies in order to serve as examples to anyone using these tools. You can also make your own surveillance designs public by changing the access. I will use this example in this video, and since it's public, you can follow it if you create your own account in the web tool. Clicking on Edit will take you back to the steps I showed before to create a new surveillance system. The steps are the same I've shown before in these slides, and the framework supports the user through these steps. First, by structuring what are all the details that those steps entail. Then, giving advice to decide what are the best options through the wiki. Links to the wiki are spread throughout the web tool, or you can also just Google Surveillance Design Framework, and you should find the wiki, which is public and anyone can see all the contents of the wiki. If you want to be able to post discussions or even suggest updates to the contents of the wiki, you can contact us through the Santero web page in order to ask a membership code to join the wiki. The structure of the wiki mirrors the structure of the surveillance design framework. While in the web tool, you find a way to take decisions and document each of those steps. In the wiki, you find information that will support your decisions. So for instance, we are right now in the surveillance system step, and we've been asked to define our surveillance objective. So we can read here through the information in order to take a decision about each of those questions. The framework, therefore, structures the steps, the wiki provides advice and support, and then you can come back to the framework, take decisions, answer the questions. And as you go through those steps, this information is being saved to be reported later. On the susceptible population, you can choose all the applicable species. RISKSUR was particularly focused on the design of risk-based surveillance, so you can find more information on the wiki about how to set the risk characteristics, which you set at this stage, but later during the design will be important in order to consider your options for risk-based design. And in this last tab, we have listed things that are important to document, to think about, and they will be documented for future reference. When you finish creating a surveillance system, you're taken directly to this report option where you can save as a PDF or an Excel. So every detail you document here can be saved for future reference. Once you have created your own surveillance system, or if you want to pick one of the public ones, you can click on it to activate the surveillance system. You can see here on the top right whether there is and which is the active surveillance system. You can also quickly change. Once a surveillance system is designed, the next step is to do the detailed design of each of the surveillance components. Going back to the structure, we have defined our surveillance system, and we now need to list all the components. The easiest way to think about the components is as activities, defined generally based on the species they are targeting and where those samples are going to be collected, for instance on the farm or on the abattoir. Therefore, when you start designing the components, the recommended first step is to make a general list where you add in bulk all the activities that you can think about as part of that surveillance system. You can add a name, and here you can only choose the species from the susceptible species you have listed before. And the other columns listed in this table are the common key characteristics that define specific surveillance activities. Again, I'll revert to the example we are using in this video where we have listed 5 different components and then duplicated the bulk milk sampling component in order to try to redesign it based on a risk-based design. Once you have listed the main activities of that surveillance system, for instance, collecting samples at farms of dead calves or clinical suspicion bulk milk sampling, the next step is to do the actual careful design of each of those components. So you have to go through these steps 3 to 14 for each of them. You can, however, go through these steps in parallel for all the components. So the first step would be objective and target population. This is the first section. You can see all the components you have listed here in the top. I'll leave the risk-based one out for now. The green fields are the information that you have already filled out in the Add Components overview and are just pasted here. You can also add more information about each of those options. For each of these sections, you have a number of specific steps. The framework will present you with the steps that compose that section, explain what each of the steps is about, and ask you to provide an answer. If you have any doubts about what to answer or how to fill any of those steps, you should refer to the wiki, where, as shown, the structure mirrors exactly the steps of the surveillance design framework. All data are saved when you click Next, and you can just keep going next to navigate through the sections, or you can use the menu to jump to specific sections. As you see, some sections seem more appropriate to passive surveillance components, such as suspicion and enhancements, and some may be more relevant to active surveillance, such as sampling strategy. The framework does not do a clear-cut separation between active and passive surveillance, so users are invited to think about each of those sections for all their surveillance components, in case there are some components that don't clearly fit as active or passive, such as, for instance, event-based surveillance. Even in cases where you're asked to give numbers and information to, for instance, calculate sample size, the framework is just advising you that you need to collect that information, and it will advise you that you need to calculate a sample size. In the same web tool, you find statistical tools that can help you with those steps. The framework itself does not do any of those calculations. It just guides you through the steps, reminds you that you need to think about all of those details, and helps you figure out where the information you need in order to do so. Within the sampling strategy, when you come to the step of risk-based allocation, you're presented with the risk characteristics you have entered earlier and guided through thinking about how those could be helpful with risk-based allocation. Again, you can go through these steps or get help through the wiki. This exemplifies how the framework can help you with not only design, but also redesign. We could, for instance, put the book milk sampling next to the book milk sampling risk-based. Refer to the risk characteristics and identify how a risk-based allocation can be done. We can later use the EVA tool to develop a plan to compare those two components. You can refer to the resources of the evaluation tool in order to understand how that could be done. If you decide to redesign your surveillance component, you can refer to the section in the wiki, Redesign Surveillance, where you can get help about how to redesign your components in order to achieve different specific performance attributes. And as I said, the parallel design will allow you to design a new component next to the old component. The redesign section will identify for you what are the key steps that can be changed and how they can be changed in order to achieve that specific, improve that specific performance attribute. So you can, in the surveillance design, just navigate to those specific steps and design the old and the new component side by side. So we have shown how the surveillance design framework supports design, redesign, and documentation. As for the surveillance system, reports are available for all the information you have entered for specific components. Explore all the steps in this tool. Remember, you can use the case study that is already filled in if you need an example. Refer to the wiki for help. And if you still have doubts or need help, don't hesitate to post a discussion or contact us. While the framework is a tool provided by the project, the wiki should be kept alive by engaged users. We have provided references, guided tours, glossary, and examples in the wiki, but through the discussion and the active participation of members, we hope the wiki will be a live tool to support surveillance design. Links to extra resources I've mentioned in this video are pasted in the information section of this video, or you can pause here to copy these web pages. In name of all the team that developed the tool, we thank you for watching this video.